Okay, we are going to talk about question 32 in this question. In the previous video, I say that I'm not very comfortable with the question because there is some ambiguity. I feel that both option A and D are valid, but after I give it a second thought, again, similar argument with question 4. This is MCQ, and if you have two options that satisfy the question context, you have to choose the option that is of a better fit. So based on this argument, we can narrow down our option to answer D. So now I will present to you the steps on going through this, but before we attempt this question, you should have the basic understanding that point P, Q, R, and S and T, they are the center of either compression or refraction. So I'm pretty surprised that let's look at the data, that actually there are 11 of you who choose option B. If you choose option B, you were saying that your Q is compression and your S is refraction, and definitely this is a wrong understanding. The up next to the center of compression, it must be the center of refraction. This must be the center of compression. This must be the center of refraction. This is basic content knowledge, and we have went through this in class. So it really shocked me when I see so many of you choose option B. Now, if you still do not understand why the center of refraction must be next to the compression and why it must be alternating, why is it that it is at zero displacement, then please come and look for me during the holidays. Okay, find an appointment. So once you have this content knowledge, you basically narrow down to two options. Either you have C, R, C, R, C, or it could be R, C, R, C, R. Okay, so it's either case 1 or case 2. Now, if you look at the question, it states that this particular displacement and distance graph is taken at time equals to t, and you are asked to describe this graph after 2 periods. Actually, this tests your understanding of what 1 period is. 1 period refers to the time taken to generate one complete wave. So if you fast forward the time by 1 complete period, you will get back the same graph. Okay, as long as you fast forward in steps of 1 period, you will get the same shape because 1 complete wave has passed, and each complete wave is a repetition of the previous one. So as long as you fast forward the time in steps of 1 period, you will get back the same graph. Okay, so with this understanding, then actually the actual question is asking you, is it CR, CRC or RC, RCR? So that is also the part whereby it bothers me. So let me further elaborate. Let's move this webcam to the top. Now, if you write, let's assume the first case, CR, CRC. After 1 complete period has passed, you will get back the same thing. Similarly, down here, you will get back the same thing. Yeah. So now if I shown it in terms of particle, I will have something that look like this. The red color dots represent the position of each particle before the sound wave passed through. They are the displacement equals to 0. So this dotted line give you a guide on the original position of the particle. So if let's say we assume that at P it is the center of compression, that means the second particle will have already been squeezing towards here. Okay, which also means that the third particle, because we know that it is zero displacement, must be the center of refraction. So at time t, it will look like this, and it corresponding to the graph that goes like that. Okay, and by this logic, you can see that your option A, center of compression P and center of refraction Q, actually is satisfied the problem context. Now the problem is with D, S and T. S and T, if I follow this logic, S would be the center of refraction and T will be the center of compression. So the question now is, how? Because if you choose D, if let's say you use the second argument, if you use the second argument, RC, then it will still make sense. So how do you differentiate which one is the correct option? It really lies here, this part. If you use the standard convention, usually in physics, we take it as if the particle moves to the right, we call this a positive displacement. Right? And if you look at our assumption here, CRC, which is this guy here, you will see that the second particle next to P is moved to the left, meaning that my original particle is here. It has now moved to the left, and by standard convention, moving to the left is actually negative. So if this case is true, I should have a graph that looks like this instead. If I take it as left displacement is negative. So down here, this one corresponds to this part here. So since this is an MCQ, we will choose the best option, and the best option will follow the conventional definition of positive, meaning that positive is to the right. And if we take positive to the right, then this thing down here, let me see if I can erase it. Oh, I can't erase this. No, cannot. So how will it look like? Let me erase this. If I take the standard convention, then 1, 2, 3, 4, 5, 6, 7, 8. Let me draw this out. Then if we take the standard convention, meaning that down here, can you see that it is a positive displacement? Convention says that positive displacement is to the right, meaning that down here, it will move to the right. Right? Then it will be down here, this guy. So let's label this up. P, Q, R, S, T. Oops, forgot one. So if you look at the part immediately after Q, the part immediately after Q is in the negative region of the graph, meaning that it moved to the left, right? Let me re-illustrate. So the particle next to Q is actually in the positive region, meaning that the particle must move to the right, and the particle to the right of Q is having negative displacement, meaning that it has to move to the left. So with this, then you can conclude that, oh, this must be my center of refraction. This must be my center of refraction, followed by this. So with this argument, then we can then select the best option that describe this, which is S being the center of compression, T being the center of refraction. Okay.